Good morning, good morning. All right, well, let's get started. Got a few people here. So I thought we would just do the method refinement tutorial, kind of go through starting with a somewhat broad set of, I mean, it's not very broad by modern standards. With what you can get much broader, obviously, with swath DIA, but sort of broad for a targeted experiment, and we'll go through how we would get down to something more refined. So just kind of go through, it's label free, but go through something that might look a little bit like an assay development, where you start with a bunch of things and you're going to get rid of some stuff, because for whatever reason at this point we're going to get rid of stuff that we just don't think we can detect. So if you go to your flash drive, can we see the screen? Not really. Yeah, it's pretty dim. No. I guess we could also try closing more curtains. I don't know. Is that? Maybe we'll see it now. Okay. I know people can move up if they. Yeah, it's not as bright a projector, I don't think. Can we? No, turn on brightness. Yeah. Okay. Okay. Well, this is what we have. Kind of people. Yeah. Anyway. Okay. So. So on your flash drive, under data tutorials, there are these two method refine folders, method refine and method refine supplement. Yeah, go ahead and grab, actually I better check to see if I've got those. Yep, I do. So grab them off your flash drive and copy them to your documents directory. Method refine and method refine supplement to the documents. And they should come pretty quickly. It's all SRM data, so it's pretty small. If you want to work with big data, or larger data anyway, you gotta come to the capstone, and there we're gonna work with some larger files. And do DIA. All right, so let's see, what did we copy? In the documents in method refine, we have this worm unrefined file. We have some scheduled replicates and two unscheduled replicates, and then if we go up to documents, the method refine supplement has all these individual worm files. So these are individual measurements of peptides that we're interested in. You can see. Did we do? Yeah, we went over for IRT. We went over exporting multiple methods to cover a document. People remember that? So we exported 2 transition lists because we couldn't cover everything in a single transition list. And so these 39 MZML files come from exporting a single document. So let's go back and open the document. Go back to method refine and double click on worm unrefined.sky. Okay, so we've got this document open. It's actually already got files imported into it, so you can see all the little dots sort of expressing that we have chromatograms. But we're gonna re-import that data. So just go edit, manage results, remove, and then click OK, and the data is gone. And now what we have is we have a file with how many peptides? 225. So it's not a particularly large file by modern standards, but at the time we were interested in looking at. We wrote a paper on using spectral data for using spectral data as a source for SRM transitions. So this is back in like 2009, 2008, 2009, and we were unsure whether you could use like you could use data from an LTQ to choose transitions for SRM. So we just took our lab does a lot of worm research, C. elegans research, and so we took a spectral library that we had and just took a whole bunch of peptides from it and tried to, I think this is probably just like a worm lysate or something, and then we tried to measure all these transitions. And so now what we're going to do is we're going to redo this experiment and go through the refinement step of just determining which ones of these things are measurable in a triple quad. So right, we clearly have at some point measured all of these things with an LTQ, and now we wanted to see which ones we could use for quantification. And we might, in the end, we're going to import 5 replicates, and then we might be looking at, okay, well, we've got 5 replicates. What, do we have reproducible measurements? Sort of like what we were talking about yesterday. Okay, but let's save the worm unrefined document. We can take the library match tab here and just move it over here to leave space for the chromatograms. So I just dragged it and attached it to the right side. Hopefully you're getting pretty good at that. And then I would go File, Import Results, and it's going to be one new replicate, and I'll call it unrefined. So I'm gonna import multiple files, but I'm just gonna let Skyline stitch them all together into one pass over all my peptides. So click OK. Actually, let's cancel. Let's go ahead with let's go single injection replicates just to see what that's like if we imported all these things as single. So if we just took the default instead of doing the one new replicate, let's just get a sense for what that ends up looking like. Because I've seen people send me documents like this, and it's a mistake to do this. So, but it's so easy because a lot of people just get used to going right by this dialog. So let's click OK with single injection replicates, and then we're going to go up to method refine supplement, where we have the 39 MZML files. Everybody have that? Pretty good, ready? So I just select those all by dragging a box around them. And click open. Now Skyline's saying, hey, they all have a common prefix. Do you want to remove the common prefix? And we'll say, sure. And that'll give us very short names for all the replicates. Because eventually we're going to get rid of all these replicates. So you might get some new windows. I've got the retention time replicates popping up, and my peak areas are here. So I'll take the peak areas and dock them with the library match tab. So I just drag the peak area tab. Does everybody have peak areas and retention times? Did everybody get them or no? Okay, well, if you didn't get them, then the way to get them, so here I've now got them both floating and the data is importing. I guess the data is all imported. And then so you can, to get them up, you go view retention times, replicate comparison, and then view peak areas, replicate comparison. And then you have, maybe you'll have them floating or whatever. And then I'm going to take the peak areas and dock them right here on top of the library match. Just drag right to the middle of the library match. And then I'll put the retention times down below. And then I'll give myself a little bit more space for that. And so now if I want to look at the library match, I can switch to it. If I want to look at the peak areas, I can switch to it. So, yeah, so I've got all these replicates, but you'll notice that like when I click on something, there's only one bar, right? It's only showing up in one replicate. And then if I switch replicates to 2, now I get this next set, but it's still only showing up in one replicate. And then if I switch to the next one, then these show up. And so this is kind of a hassle because if I want to find, I mean, the graphs make it somewhat easy. If I click on some peptide down here, the graph shows me what replicate it's in, and I can then hover over this bar and activate it. But I really would rather not have all these tabs and all these replicates to go through, that where everything is sort of separated and measured in one replicate. So that's why I want to have the that's why I didn't want to import these as single injection replicates, because they're not really replicates of the replicate measurements. They're all disjoint measurements covering the same, you're covering the full target list. So let's just, all we have to do is go edit, manage results, and then we'll just remove all. Everybody got that? And okay, and now the data hasn't actually been removed from our file, and if I click undo, it'll all just come back immediately, and then redo, I can get rid of it. So we can now reorganize the data by doing an import again, and it won't need to re-import. So unless we save, if we save here, this will get committed to the document, and it will be empty. But if we don't save, we can go File, Import Results. Whoa. I'll close that. File, Import Results, hopefully. Okay. So everybody here at File, Import Results. Okay, and so then we're going to choose one new replicate. We're going to call it unrefined, like I said we might. We're not doing any optimizing, so click OK. Import results, one new replicate, unrefined. And then click OK. And we got to go back up to Documents and then down to Method Refine Supplement. And then select all 39. People following. And then click Open. And then it's just sort of instant. Skyline's done everything, and you can see that everything is organized like this. If you just came in Are there people who haven't, or like raise your hand if you haven't even, if you're not really even started? Okay, so if you just came in to get started, you can now join us pretty much by going to the flash drive and copying from data tutorials. Just copy method refine into your documents directory and open the worm unrefined.sky, and you'll be right where we are. We just sort of went through a bunch of steps to show how we would get this data. I guess actually I meant to show how we would get the method files for this, so let's quickly do that while the people who just came in copy the method refined folder and open the worm unrefined document. So I'm going to save what I have. And I might also now go to view retention times and reopen the replicate comparison and view peak areas replicate comparison. And you can see that now there's only one replicate, there's unrefined, and you can see next to it, Skyline is showing us what it's expecting the distribution of the library to look like. And then you can see here this one retention time, which is not all that interesting. How do I get what? Oh, library matched. For me, it's behind. How do I get it behind? Where is it showing up for you? You have it stacked up. So yeah, I mean you can if you had it like this, so stacked up, you would grab onto the title bar, and then just put your cursor in the middle of the peak areas, and then you want to go right in the middle of that cross, and then release, and now they're on top of each other. Okay, so let's look at what we would do to get a transition list for this. How many transitions do we have? 2,000 transitions, so way too many to measure in most mass spectrometers. So what we needed to do is run multiple replicates. We can do that by file export transition lists. Thermos again, fine. If we were yesterday, we ran some runs where we had 340 transitions per injection, and that would give us 7. Oh man, I gotta take that thing out. That would give us 7 methods. Skyline's telling us if we had 340 transitions, it was 7 methods, and if we I think what we had was 59. Yeah, so if you type 59, so I guess we had a much slower triple quad back then, and the mass spectrometrist wanted to make sure of getting pretty good data with a fair number of points across the peak. So she just did 59 transitions per injection. It sounds like, somebody suggested yesterday that they would be comfortable with 200, so that would be 11 methods. So even with a triple quadruple, you can test a fair number of things, and then Skyline will stitch it all together as if it's just one data set. But yeah, so let's type in 59. Now we get the 39 methods, and we could then export those to documents. This is just so well. Let's go ahead. Let's go through it, and we'll take a look. So if you click, so if you just put this, and we'll call it worm. Actually, let's put it in the supplement. If you go to documents, and you have a worm, I mean, it doesn't really matter where you put it, but if you put worm as the name, right? So we're gonna put these files. They're gonna be transition lists. We're gonna put them in worm and method refined supplement. Click save. So we told Skyline, hey, my mass spectrometer, I only want to measure 59 transitions per run. right? So now if I go here and look in documents, method refined supplement, you can see that I have a CSV file, and you can see, coincidentally, they match up perfectly with the MZML file names that I just imported. So, and then if you look at one of them in Excel, you'll see that we have a Q1 and a Q3. So SRM, triple quadrupole parameters, collision energy, the peptide I'm measuring, the ions I'm measuring, and then you'll see in this case, there's only 49 transitions in this run, because I said 59 is my maximum, and the next peptide must have more than 10 transitions to measure. So Skyline's just walking down the list, and anytime adding another peptide would give it more than 59 transitions, it breaks it into another file. So then if we look at the next one, we should see that the first peptide has more than 10 transitions. So here you can see it's got 13 transitions. So that's why it got kicked into this next run, right? And then this one goes all the way to 57, so pretty close to our maximum. So that's what's happened. Every one of these then MZML files, which was originally a .raw file, got some number of transitions. And that's why when we opened it up as replicates, we could see little blocks of measured peptides. Each run was measuring a different set of peptides. But now it's all stitched together, and we can't even really see the file boundaries most of the time. So let's look at some of the data. Here is one. So what do people think of this peak? We can, if we expand the peptide, we can see that the .p is 0.75. I don't think much of this peak. I'm zoomed in. Is everybody zoomed in, or are there some people that see the whole range? Okay, so what I tell people that I think is one of the most important keyboard shortcuts in Skyline is F11 to zoom in and Shift F11 to zoom back out. So we can see that there's a 90-minute gradient. We've collected chromatograms across the entire gradient. It's unscheduled. And so that's the rest of the data. Like you could consider zooming in and looking at some of these other large peaks. But what you'll find is most of them have one or two co-eluting transitions. And Skyline's really done an okay job at picking the most probable thing where there's a bunch of stuff, but it's not really a nicely co-eluting peak, I would say. So what I would do is I would just delete this as a candidate and just say, yep, this is not measurable. And then the next one, if I do F11, that's pretty nice. Everything's co-eluting. There's no, if something is not co-eluting, you would see some color along the x-axis, but everything is co-eluting. But we have a .p of 0.57. And in this study, that turned out to be one of our outliers for correlation. So one is perfect correlation, and 0.57 is really not that good. And the way we eventually explained this was that if you look at the library match, and I'll pull it out here to make it bigger so that everybody can see clearly. And I'll even properties, I can make the font size larger. So you'll see that the two most intense transitions here are B10, are Y10 and B10. They both have this mass, and Y12 and B12. And we've chosen to include it because it's a Y10 or a Y12, which we said we want to include all the Y ions. But do people know the difference between B ions in a triple quadrupole or beam CID versus trap CID, resonance excitation CID? So B ions, I mean, in a simple way of thinking about it is in beam CID, so that's what's happening in a triple quad, is that the molecules just get dragged through a gas. You'll get multiple fragmentation, and that tends to chew up the B ions. So B ions in most beam CID they end up being really, you end up with mostly B3, B2, B3, very small B ions. So whereas in resonance excitation, as soon as one fragmentation happens, then it's no longer the right mass and it gets ejected from the trap. So that means that we see B ions way more intensely in a trap than we do in beam CID. So basically what we can assume is happening here, and if we look at Y10 and Y10 and Y12 here, so these are supposed to be the most intense things, and you can see Y12 is the 10th most and Y10 is the 4th most. So they're not the most intense things. And we can assume that that's because there's not the contribution from the B ions. But if you look at, well, Y9 is not actually particularly intense either. What is it saying? Y4? Y5? So those are, reasonably intense things here. And then Y3, which is really not that intense. Huh, interesting. Okay. Well, that's we eventually decided that we thought that this was probably the right peptide, and it was really the lack of Y10 and B10 that was really messing things up. I guess one thing we could also do is we could see if we Y12 and B12, so you could click and then click the second one and then delete for a second and then see, well, the dot product doesn't get that much better, does it? It's 0.6 now. All right, well, anyway, moving on. So you can decide for yourself whether you believe this is actually the peptide of interest. It does have coelution on everything, and there's some pretty big Y-ions here, so. And these spectra were collected on completely different, they were collected on an LTQ versus triple quad. So next, let's move to the next thing. Here again, I think we probably decide there's just not anything. The highest intensity thing we see is 5,000, and we can zoom. Yeah, the red dot is telling us, well, the red dot off to the left is telling us that what is selected is garbage, right? So, but we might, you might wonder, well, maybe really, Skyline's pretty good, so it's not that likely that there's some beautiful peak around here somewhere. Let's see. No, yeah, so I don't know. There's a moment where, a bunch of things coalute but they only go up to 100. So, yeah, you would say, I think you have to say, yeah, we just couldn't detect this. And as you've heard that, you might be able to detect it if you did the right sample prep, but this is just a very simple sample prep with a worm lysate that we're looking at. Okay, so now we go to the next one, F11, and that one looks really beautiful. And its dot product is, might be on top of here. Yeah, its dot product's 0.87, which is good. And the one after that is 0.9, and the one after that is 0.9 as well, and has tons of ions. So these first four look quite good. But now let's quickly, we don't have too much time left, so let's go to how we might also, so you could, I mean, actually, there's only 200 of these things. You could probably go through them all manually in an hour or so. But let's go through what you might do to get to something that's more refined more quickly. And the first thing we'll do is to look at view retention times regression score to run. So we looked at this already with IRT, but in this case we can, you might, I don't know, do other people have a graph like this? So this is because I'm forcing it to look at Biognosis CRT, and it's saying it's IRT, and it's saying, hey, none of these peptides are in there. So I'm going to switch back to Calculator Auto and let Skyline, it will pick SSR Calc 300 angstroms. So this is a regression. There's plenty of outliers here. But there's also some stuff on the x-axis. Do people know what the stuff on the x-axis is? Right, you see some points down here? What? I did view retention times. So these are retention times. Regression, score to run. Oh, and then I right-clicked and chose Calculator Auto. Or you could choose one of the SSR calcs if you wanted. Okay, so you can see that the little red dot represents our selection, and we could quickly kind of go select our first three things or those four that we thought looked pretty nice, and see that they're all fairly close to the line. So you can just watch the red dot move around and say, oh, okay, that's the selected thing. And so the first four that we've decided, yeah, we'd like to keep those, they're all also really close to the line. You can then, in this graph, you can click on anything you want. So you can click on one of these big outliers. And I'm going to move this over a little bit so that we can see the chromatograms. But if I click on one of the outliers, I'm expecting it probably won't be very good. Yeah, so that's like, I don't believe that either. And you can click on, no, there's one. It's got a really bad .p. Okay, so do people, like, you see this? This looks like a peptide, right? It's some kind of peptide. It's got, what has it got coelution on? So another thing you can do is if you put your cursor to the left of the y-axis and use like a scroll wheel, you can kind of scroll down in to look at these things. And I would say, yeah, I maybe believe that there's definitely coelution on 2 transitions, maybe 3. So what would people say the transitions where there's coelution? What are they? What? Yeah, let's see, the Y5. The Y5 is this tannish thing, and maybe, I don't know. I would say that obviously the Y4, which is this, and we can, again, if you're not sure which one's which, you can select them. So that's the Y4. You can see these little hash marks that say, and the number 15, which tell us we have 15 points across the peak. And then you can look at this other one, which is Y3, which is probable. Y5 is not that probable, and then maybe Y6. But Y3 and Y4, so why should we not trust when we see co-eluding Y3 and Y4, but not really anything else? Well, we want more, and our spectrum tells us that Y7 is the most intense thing, should be the most intense thing. So Y3 and Y4 are least selective ions, right? It goes from Y1, which is always K or R, Y2, which is K or R plus some amino acid, Y3. So they're very common. And so yeah, if somebody shows you something like this and goes like, look at my beautiful, look at my beautiful peak, and even if they maybe don't have the dot product number up there, you should be very suspicious with only 2 ions really co-eluding well. And especially you should be looking at how big the ions are, because if you have a Y12 and a Y10 co-eluding, that's more convincing than a Y3 and a Y4. Okay, so let's look at what these things are on the x-axis. So go ahead and click on a point on the first point on the x-axis we can click on, and now you can see there's this bare patch with no dots, right? And this YLAEV, Yalive, this peptide, that's what we're on. It's not there. So what does the missing dot mean? There's no measurement, right? So it's not that we measured it and we didn't find a peak. It's that there was no measurement at all. Measure it and not really finding a peak would be a red dot. So you can see that there's a whole missing swatch of peptides altogether. And then let's see if you select the peptide above. Whoa. I'm going to do Shift F11. What happened? Shift F11, F11. So there's my peak. If you weren't seeing your peak, the graph might have been zoomed in, so you just go F11, Shift F11, and then now we're zoomed in to the peak. But you'll also notice that above the graph there's a drop down for file, and you can see that this peptide was actually measured in both file 27 and file 28. Right? And then you can look at file, we got pretty nice measurements of it both times. So we actually have replicate measurements of this peptide. Let's look at the next peptide above it. That one looks pretty nice, and it looks pretty nice in both runs. So can anybody tell me what happened? Why do we have 2 measurements of this? We have no measurements of the ones below, and actually, so each file, so you can see files 27 and 28 contain these, so they have replicate measurements of these 6 peptides, and we're missing measurements for these 7 peptides. So what happened? Yeah, so 27 was run twice. So that, again, when we have a transition list, so you export a transition list, then there's a manual step to merge those transition lists into method files. And it seems like the mass spectrometrist who did this, who's actually one of the more meticulous people I know, she, in the process of creating 40 methods from transition lists, she mixed one up, and then actually, if you look down here, there's another one that got mixed up too. And you can see that if you look at the peptides below the empty spot here, they got measured twice too. So in this case, 36 got measured twice. And so we didn't actually get measurements of everything. Okay, so how did I get this? Well, you have to actually, so to get the file numbers, you have to select a peptide. So if you look at the first missing swatch and you select the peptides above, then you'll get file. If you select the empty peptides, you won't even get a graph. You didn't get that? She wasn't on the right peptide. I don't know whether. Yeah, so it's only going to happen for the peptides that were measured twice. All the ones that were measured just once, they don't have a file drop down, right? It's just like, yep, there was a file. It was measured in. In this case, we only did it in one time. So we're good. The idea is that this is one. So we talked about that method refinement cycle. This is one trip around the method refinement cycle, and it doesn't look like we're going to have time today. But if you do this tutorial, we take you all the way to where we have replicate measurements, by that time we're doing scheduled SRM. We can do it in one injection. So this is just like the reason we had to do this was because we didn't, now we have a whole bunch of methods that would help us get through this more quickly. Like one is if we had measured them ever before, as we clearly did, we would probably have IRTs for them, and we'd be able to schedule just by measuring our IRTs on our gradient. So our first run, we probably could measure everything in just one run. So we have tools that allow us to measure a lot more things in a first run. But what I wanted to show you is just like, and then there's also potentially using DIA. But I wanted to show you the idea of like, okay, here we have these not so great measurements, and if you're sticking around for the capstone, we'll go through DIA, and you might get a set of potential targets through DIA, and then you would definitely have IRTs. You'd have retention time information, and you could really, with scheduling, we should be able to measure thousands of transitions in a single SRM run even. Okay, but yes, this is the way we did it. We were just like, well, can you do targeted proteomics, sort of brute force? Because when we started, we were working with CBTAC, and they were just ordering synthetic peptides and synthetic proteins for everything. And we were like, well, can we get some? We're a poorer lab. We don't have the money to order quite as many synthetic isotope labeled peptides. Can we get an idea of what we think is measurable before we start ordering peptides? Suppose we wanted to measure a specific protein. If you want to measure a specific protein and you know that, okay, there's only 20 potential peptides that I could measure, you could measure all that in one run and figure out which are your best responding peptides, and then move on from there. So we're sort of simulating that type of thing. Since we don't have a whole lot of time, let's quickly just jump to what we might do to narrow down this list fairly quickly. We could go to Edit, Refine, Advanced, and we could say, well, we're not going to do min peptides per protein. I don't think we need anything on there, so we're just going to go to the results tab, and we're going to say that we want the maximum peptide peak rank. Let's say we want it. In our next round, we're going to measure only 5 transitions per peptide. Oh, that's not the max. We want the max transition peak rank, and we'll say 5, and we'll say prefer larger product ions. So that just says, okay, you maybe measured 12 in this run. We just want to measure 5 in the next run. We're going to say remove nodes missing results. And then retention time outliers with an R value of 0.9. And our minimum dot product of 0.8. So we can set some parameters without ever looking at the data. We can just say, okay, we imported a bunch of data and we set some parameters as cutoffs. Everybody there? Edit, refine, advance, and then we click OK. And now we're down to 85 peptides. You can see that they're, we've sort of cut off the outliers in retention time space. And if we go down fairly quickly through this data, you see that it's pretty good quality data. And if we decide, well, that looks so good, let's be a little bit more lenient, we can just undo and then go edit, refine, advanced, and results, and we can say, again, 5, remove missing, and then now we're here, and we might say, well, let's take, 0.8 and 0.75, or 0.7 even, and click OK, and we'll get more things. Now we have 121 peptides, and I would guess that if we went down through here, we're going to see some things that, well, I guess, that's 1 point across the peak. But still pretty decent data. So this might be enough to take to our next round of refinement. So that, cut our set of the things that we are considering in half, but still gave us, reasonably nice. Well, that, I don't know what's up. Oh, that's not that great. So yeah, so there are going to be some things that aren't that great here. So let's go, we have like 5 minutes left. So let's quickly, so this would be potentially, well, let's export this as a scheduled run. We've got measurements for everything, right? So we could now export a scheduled run. So we go to settings, peptide settings, and you got to check prediction, and then you have to decide what your time window is going to be. Actually, let's go look at the scheduling pane again. We have 600 transitions, but if we go to view retention times scheduling, pull that out here, we can get an idea of what the windows could be. So in this case, if we have a mass spectrometer that can measure 200 at a time, we could use a 10-minute window, or if we're comfortable with 100 at a time, we can use a 5-minute window. So let's go with a 5-minute window. So you might go settings, peptide settings, and you say use measured retention times when present, and it's going to be a 5-minute window. So we don't need a predictor because we've got measurements on our chromatography. Click OK. And then now we could go File, Export, Transition List, and if we switch to scheduled, then you can see if we have 59, we're going to get 2 methods, and it's saying maximum concurrent transitions. And if we went up to 90, we still have 2, but if we go up to 100, we get 1. So if we're willing to have 100 transitions, we'll get 1 method, so we can just say single method. And OK, and then we could export that as scheduled. So that's because, I noticed you have two tabs. So you missed the step where you were supposed to remove. So I have one tab unrefined, but yeah, I would just say use the unrefined replicate. You get to choose a replicate. All right, so now I'm gonna undo this back to my original set of peptides and edit, manage results, remove. I'm gonna remove all, so I have no data again, and save. And we can see this time we're gonna go file, import results, and I'm just gonna do this quickly because we're out of time. And now we do single injection replicates, and we can import these 5 scheduled replicates and pretend that this is basically what we did. And we can have replicates, we can just name them, or you can delete some of this and keep rep. So repo 1, repo through repo 5. Those will import pretty quickly. But you can see that they don't cover, so I just left everything. Here's 2000. They don't cover quite everything, not nearly at all. But I can use edit, refine, remove missing results to get my set of things that were actually measured. You can see that in my final run, I only measured 3 transitions per peptide. And you can see that I measured 65 peptides. So I guess after the final refinement, I ended up with far fewer than we just did with our thing, but we have pretty decent replicate measurements of those. We could get a sense for how well we did with peak areas CV histogram, and you can see that 87% of the measurements, when normalized to medians, it doesn't matter. So yeah, we have our median. Well, we're not going to normalize to medians. Our median CV is 7.7, and most of these things we can measure below 20%, but we might get rid of everything that we couldn't measure below 20%, because maybe they're degrading peptides, or so we're going into a new round of refinement. We can continue to go through these refinement steps and get to where we have more precise peptides that will give us more precise measurements of the things we're trying to measure. And so that's one of the key concepts. I think we're going to hear more about that today. Key concepts of targeted proteomics is that you can use method refinement. And certainly if you're going to take anything to the clinic, you're going to need to use method refinement to get to where you have very precise measurements, very repeatable measurements. And yeah, so we did a little bit of that this morning. That's it. Yeah. How to export reports. No, I have not showed them how to export. Okay, sure. Okay, so we definitely played with the document grid when we did yesterday. For people who showed up, we were definitely playing with the document grid a fair amount. So here again is the document grid, and it just comes out to peptide ratio results, which is what I was working with yesterday. And so anytime you're in the document grid, as I think I mentioned, we call it a live report. You can always just click export, so whatever you've got in the document grid, you can export as a CSV. We also have the ability, so you maybe remember that we have this views with all the, and I have probably more reports in here, custom views than you do, but we played with peptide quantification and peptide ratio results a fair amount yesterday, and also with replicates a little bit, so where we set the analyte concentration and the sample type. So these are all reports, and you can create your own. Like I have one that says transition counts, and here I have, you can see it's all 3, but if I went back to my older document, actually if I just went undo then I go back to a document where each peptide has a different number of transitions, and I can do things like sort. And now I can see that I actually have one peptide where I only had 3 transitions in this initial phase. So those are all custom reports, and you saw how you could edit the view, or you can create custom reports from like proteins, and then customize view, and then you create a custom report in here. There's and so you can always get that by clicking export. You can also get all the data out of it by clicking copy and then paste into Excel. And then finally there is, I think what Lindsay was referring to, is file export report. And then all of these things show up again, and you can even preview them. So we could go to peptide ratio results and preview it. Now we get another copy of that same. This is just like this is a preview, but it's basically the document grid. And then once we're happy with the preview, we can export. As you install external tools, who has Quasar installed? Does everybody have Quasar installed? So Quasar has its own report. So you should see like I have SRM Collider, which I can preview, and you can see this tool written by Hannes Rost of the Aebersold lab. This is the data it needs to function out of Skyline. And then maybe do people have a Quasar report? Everybody who installed Quasar under external tools, is there a Quasar report? Yes. So you could preview that. Did anybody who's installed MS Stats? Not so many people. Okay. So but they'll still need the report. Yeah.
Perfect. In Skyline, we can export these types of tables to use in MS Stats next.
Yeah, and so every tool, that's one of the things about external tools. One of the aspects of external tools, you get to define a custom report, which is your data format that's the input to the tool. And so MS Stats has one. You can, if you want to share. So let's say I had created the coolest set of reports that I wanted everybody else to have. One, I can edit this list, and then if I select several of these, I can select as many as I want actually, and then share, and then that will create me a .skyr file, which is just a set of reports. And when I was part of that fit for purpose group, we were asked what should people include with manuscript submission, and I thought, well, they should include all the reports that they used in Skyline. They should include their Skyline document plus all the reports. And so that's why now in settings, document settings, you can also go to here, reports, and just check off the reports that you use. So if you use peptide quantification and peptide ratio results, and maybe you did the customization that we did for you didn't use the standard peptide ratio results. You did what we did yesterday, which was to add the columns for accuracy and the actual analyte concentration. So you can just check those, and then now when you upload your document to Panorama for publication, as you should, then it'll come along with its reports. And so if anybody gets your document, they can export the same reports. So there you go. That's it for this morning.